Okay, everybody, in this video, I will discuss chapter 10, and it's about polymorphism. So I will use this, what is mentioned in the lecture notes in the book, those concepts, okay? Holiday and Christmas and other holidays. So I will make that into a program and we will look at it to understand all the concepts, the late binding, polymorphism, and casting, etc. So let's look at this holiday um, class, okay? So for holiday, I only have two instance variables, name and date. For date, I use the string. There is actually a date class in Java, but I'm not going to use that just for simplicity's purpose, okay? So this is the constructor, empty parameter, and the constructor. You understand all this already, right? The get and set. I didn't have the set, right? Okay, let me do the set for now. Let me pause a little bit. Okay, so we have, I wrote these two methods here, set name, set date, and you have the accessors, get name, get date. So this is the holiday class. It's a very general idea about a holiday, right? So then we have a child class, Christmas. So let's look at this child class. It extends holiday, so it's a child, and it has its own attribute, which is a tree. A tree should be a class, but once again, that's not our purpose for this project. So I make it simple and make it a string. Okay, so this is the constructor. Public Christmas, it accepts three parameters or strings and calling the parent's constructor with the name and the date. If you go back to holiday, okay, so this constructor will be called, will be used. And after this statement, name and date will have a value, right? And then you add to it. So once again, you construct the parent part first, and then you add the child part. So here, this is the child part. Tree is equal to that T. Okay, set tree, and I think, oh, I do have a get tree here. Okay, I did write that. So get tree and return tree, but I put this here so that we at least can see something happening, right? Okay, and the toString, super.toString, this goes to holiday, and it will call this method, gives you back a string, and you add the tree to it. Okay, so that is Christmas. And then, as we said, there are many different holidays, and I have another one, Independence Day. This is America's national holiday. It is the, yeah, it is the national holiday. So it's a great holiday. And so Independence Day extends holiday, okay? And because we don't have I don't have any specific attributes for it, so you just call the super, call the holidays constructor there, and that's it. You don't have your own attributes to add to it. Okay, but you do have a specific method which does not apply to all holidays, and that's why you need to have this child class Independence Day, because even though it doesn't have its own characteristics, it does have its own specific behavior. That's why you have a child class. So if you think about it, if your child class doesn't have any specific characteristics, nor does it have any specific behaviors, then you don't design this child class. It's the same as the parent. So the purpose, the reason you have a child class is because either it has specific attributes that are not in the parent class, or it has specific behaviors that are not in the parent class, or it has its own version of the specific behavior. The parent has, but it has a different version, like what we did with the walk. or it has both specific attributes and specific behaviors that are different from the parent, then you need to have a child class, okay? So we have that, and we have toString, and we return the super toString plus, and it has fireworks, okay? This is all made up, just know that. So now we have the Christmas holiday, and we have Independence Day. We have holiday, and that let's look at holiday driver. Okay, so just like in the lecture notes, you have that holiday day, and then day is equal to new Christmas, right? So that's what we are doing here. Declare this reference variable. So here is the difference between a reference type and a referenced object. And I explained that in the lecture notes also. Let me just reiterate that. This type is the reference type. So what's the reference type of day? Holiday. And this is the actual object that is being referenced by that reference variable. So day is actually referencing a Christmas object. Okay, so it's a holiday type, but the object it's referencing is Christmas. That's the difference. So can day reference an independence object? Definitely. Why? Because holiday is the parent class of Independence Day and Christmas Day. So an Independence Day is a holiday. A Christmas is a holiday. So you can definitely say day equals to new Independence Day. We will do that in a minute. Okay, so now let's see. Let's print out day, right? And let's see. Okay, Christmas occurs on that day, and the tree is a Christmas tree. So that's that. Then how about, because that, okay, let's go back to where is my driver. So when we do that, we are calling what? We are calling the toString method. The system is calling the toString method automatically. And let's think, which toString is it calling? Okay, is it calling the holidays toString, or is it calling the Christmas toString? If you look at the output, obviously it's calling the Christmas toString method, right? Okay, holiday toString, return name, and that the name is Christmas, and occurs on the date, And so that's the super toString, and plus the tree is the tree. And the tree is a Christmas tree. So it's using the toString method here, right? Okay. Why? Because this is a Christmas object it is referencing, even though this is a holiday reference variable, but it depends on what type of object it is referencing. And that is actually in my lecture notes. Let me go back. Go to the beginning. Okay. And this is what we are saying, right? A binding. Okay, if you read this, this is what we did is really explaining this. So I'm not going to read through that, but you can look at that and you can see what I'm talking about here. Okay, so now if Christmas doesn't have a toString method, then it will call this method, right? But fortunately, Christmas has one, so based on the object, it's calling the method in that there. So now I want to see if we can do this. Can we do, since day reference is a Christmas object, can I do day get tree, right? That is a Christmas method. get tree. So can I do that? And you look at this and it says, no, you cannot. And why? It is because when the compiler compiles, it looks for the method in the reference type, not in the object of the actual the reference type references. Okay, once again, when it compiles, it looks for the method in the reference type. So what is the reference type of day? Holiday. So it will go to holiday during compiling. Okay, it will go to holiday to look for the getTree method. It's not there, right? That's why it doesn't compile. Now, if you do, when we do this, actually, when we did this, okay, it compiles because, oh, okay, no, it compiles definitely, but I'm trying to explain where does it look for the toString method, right? It looks for the toString method in holiday, not in Christmas, in holiday, because that's the reference type. So it goes to holiday and it has the toString method. So it compiles. If a holiday does not provide this toString method, then it goes to object and it will compile also. But when it actually runs, that's where the late binding, dynamic binding comes in. When it actually runs, it looks for, it uses the method body in Christmas because that's the object it's referencing. Okay, so that's the compilation and the actual execution. When it compiles, it looks for methods in the reference type. When it actually runs, because of late binding, because of dynamic binding, it uses the method in the object class that's being referenced. Okay, so now we do the getTree, it doesn't work because in the reference type, there is no such method. And what do? We know day references a Christmas, so we cast it back to Christmas. Okay, Christmas. We cast it into a Christmas, and then we can call the getTree. Okay, I need another pair just so that it will do the binding first. Okay, so it will do the casting first using these enforcement of parentheses. By using parentheses, you are enforcing the performance operation to go first, right? So I'm casting day into Christmas reference type at that moment. And then, so now the compiler knows that, oh, you are casting it into a Christmas. So now I should look for that method in Christmas. And so it compiles, okay? And when it runs, it also goes to getTree because the actual object is a Christmas object. So it goes to getTree to use that body of the getTree method. And you can see it is a beautiful tree, a Christmas tree. That's what the getTree does, right? So that's that. That's the late binding and it's also called dynamic binding, right? Let's do another experiment. So let's use the same variable, okay? Let's use the same variable. Day, just now we already said that, can we use it to reference Independence Day? And we said yes, because Independence Day, Independence Day, right? Okay. So its name is Independence Day. And its time is July the 4th. Okay. So we created, Independence Day. What's wrong? Day is equal to new Independence Day. So what's wrong? Let's see. Independence Day. Did I spell incorrectly? Let me pause and just, I don't want to use the time here. Let me pause. Huh, where is my, here. Such a silly mistake. You might have already found it out, but you couldn't talk to me. This is pre-recorded, so Independence Day. Okay. So day is equal to new Independence Day. Now we have this Independence Day. And so you can see, because it's a holiday reference variable, it can point to different objects of that type, of that general type, right? So now, since day references an Independence Day object, can we say day.fireworks? Can we say that? Can we do that? And you already know we cannot. Why? Because day's reference type is holiday. During compilation, the system, once again, goes to the reference type class to look for the method, and holiday does not have this method. So during compiling, it goes to the reference types class to look for the method. During execution, it goes to the actual object class to find the method, to use the method. That's why we call it late binding, right? During compilation, it doesn't know which actual version you want to use. Do you want to use the version in Independence Day, or do you want to use the version in holiday, or do you want to use the version in Christmas? It doesn't know. So, but during compilation, oh, that's compilation. During execution, it will look at the actual object. I know I was rambling just now. Okay, so day fireworks, okay? It doesn't work, and you already know how to solve that problem. We cast it into Independence Day. Okay, and let's put one here. And now, oh, so did I? Fireworks, okay. Fireworks. Okay, so now it will run, right? Okay, so that's that. And so now can we do this? Let's print out day. So when we do this, which method will it use? Which toString method will it use when we do that? Right? When we do this, day now references the Independence Day class. So during compiling, it will go to holiday to look for the toString method. When in execution, it will actually use the body for this toString method. Okay, so let's run. Oh, did we run already? No. Okay, so that is the toString method of Independence Day, right? Okay, so you understand that. Now, let's do this. Christmas equals to new Christmas. I'm going to just copy this, right? Let's create this. Christmas, a beautiful, magnificent, a decorated, a fully decorated Christmas tree. Okay, new Christmas. Okay, let's just finish it. Christmas is such a beautiful holiday. I want to use the full name for it. Okay, so now we have this, right? So can Christmas be assigned day? You think about it. That's why I'm doing this. I'm asking you. You think about it. Can you say Christmas equals to day? right? Can you do that? Can I say Christmas equals to day? Oh, no, no. Can we do that? No, why not? Because day is a holiday reference variable. It's the more general type, okay? It's the more general type. And so you cannot do that because not all holidays are Christmas days. And a Christmas is a holiday, so you can do that, right? A Christmas is a holiday, but not all holidays are Christmas. So this day is a holiday reference, and you go that way. Is this that? You always ask from the right to the left. Is the right side the left side? No, then you cannot do that. Okay. So can we do this? It won't make sense though, because we already made it into Independence Day, right? So it won't make sense. Let's try and see what happens. This will compile, but then if we print it out, what will happen? Let's see, because it will, okay, let's see. I don't know what will happen. Exception, right? Why is it an exception, everybody? Because now you can see the difference between compilation and execution, right? When you compile, this compiles. Why does it compile? While day is actually an independence object. Day is referencing an independence object. Why does this compile then? Because the compiler, even though it's very smart, it follows the rules, syntax rules. Even semantically, it's not meaningful. It follows the syntax rules. So day is a holiday reference variable, and Christmas is a holiday. So you can cast a holiday reference variable back into a Christmas. So that it allows you to compile. But when you actually run, no, I think right here when it runs, okay, let's see, right there, it would have that problem. Right there when it casts, yeah, when it casts actually, it cannot even cast, right? So right there, during execution, the runtime error, it's a runtime error. It sees that, no, I cannot cast day into Christmas because it's actually referencing an Independence Day object. So it can compile, but it gives you the runtime error. When you run, it gives you this miscast exception. Okay, so that's that. So that is that. What else? We already did all this, right? Okay, let me see what else I want to discuss. So can you cast it into, okay. You already understand the casting, right? Okay, can we say this? Can I do this though? Can I do day is equal to Christmas? Okay, you understand that we cannot cast it here because of what I said, but can we do this? Right? Can we do that? That's Christmas. Did I do that correctly? Yeah. Can we do that? It compiles. Can it run correctly? I think so, because Christmas is a holiday. So you are assigning a more specific type to a more general type, and that's okay because it's a holiday reference variable, even though currently it's referencing Independence Day, but it's a holiday reference variable. It can reference any holiday. So Christmas is a holiday. It can be referenced by day. And now when you print out day, it will print out Christmas. Let's see. Right? Okay, so that is it, everybody. I think that it explains the late binding and the polymorphism. Oh, polymorphism, then why do we say polymorphism? If you remember in the lecture notes, it says every object is a potential polymorphic reference, right? That's true because look at this, right? Day is a holiday reference variable, but here it's pointing to Christmas. So when you use it, okay, when you do the system.out.println day, it's actually referencing the Christmas holiday. And here it's actually referencing the Independence holiday. And here it's referencing Christmas again. So the polymorphism occurs during execution. Okay, so which method is used depends on what kind of object it's referencing. So once again, I'm repeating this so many times, right? The reference type and the referenced object are two different things. During compilation, it looks for the method in the reference type. And in execution, it changes to the method of the actual object it's referencing. This is the reference type. Okay, this is the actual object it's referencing. Okay, that's it, everybody.